Hey there, let's solve problem 2114 or 2114, maximum number of words found in sentences with APL. And by the way, we are in LeetCode, so this is problem 2114 of LeetCode. So a sentence is a list of words that are separated by a single space with no leading or trailing spaces. Fine. I'm given an array of strings where each sentence or each string represents a single sentence. Fine. And then we want to return the maximum number of words that appear in a single sentence. Okay, we can do this. This is great, thanks very much. I don't know why this is underlined. Oh, okay, they underlined the sentence with the greatest number of, of words. So this is... I guess this is very straightforward unless I'm missing something. So let's take... But I mean, I keep saying this as if I'm a genius, but the fact is we are solving the easy problems first. So the sentences are these. Let's paste it here. Now we need to replace these with the correct quotes. So now we have a bunch of sentences. Let's see. I can't mix them because now I have way too many, or actually can I? This is, okay, let's solve it this way. This is interesting because the standard approach, I would think, is to find the maximum. So we want the maximum number of words, right? But now what we need to do is we need to count how many words there are in each sentence. So we use the each there. Now, splitting a sentence in words is fairly straightforward, and I just say this because this is an idiom that is shown in the tooltip for partition. Sorry, we just need to literally copy the tooltip. So we're going to have a space here, and now we need to find the places where the space is different from the sentence, and then we partition that sentence, and we need to count that. So this works just fine. You can see the output is 6, and this is what we got. But this is using an each. So in APL, you often prefer solutions that are more array oriented, and sometimes that means avoiding the use of each. So I'm not saying this is a bad solution, but let's try purposefully. Let's take an effort. Gosh, I can't speak. I just want to solve this without using each. That's what I mean. So what we'll do is we'll mix the sentences, and now we want to count the words, but instead what we will do is we will count the inner spaces, because the number of inner spaces is one less the number of words. And in order to count the inner spaces, what we will do is we will count all of the spaces, and then we will subtract the number of trailing spaces. So I guess this is one way to handle this. And so figuring out where the spaces are is just comparing. You compare the space with the matrix, and now you can count all of the spaces with plus reduce. So this means there are 7 spaces in the first row, 19 spaces in the second row, and 5 spaces in the third row. Now, these are the number of spaces. Now what we need to do is count the number of trailing spaces. So how do we do that? Well, these are all the spaces. And now what we can do is, if we rotate this, now the trailing spaces are the... what do you call it? The trailing spaces are leading spaces, right? And now we use a and scan. And what this does is it takes the first run of ones and leaves them unchanged. And as soon as we find a 0, everything else is 0. So now we have only the trailing spaces here. And with a plus reduce, we count the trailing spaces. And now we subtract the total number of spaces from the trailing spaces, and we add 1 plus that, and then we compute the maximum. Okay, this was fun. So this is one way to do this. Now let me look again at what SP was. So what was the expression to build SP? Okay, so this was it. Now I'm gonna take it to the bottom and let's see if we can simplify this. So this was SP. And we can see that this is repeated. So instead, let's see if we can write this tacitly. I'll leave that as a reference. So we want to find the maximum of 1 plus. No, this is the plus reduced from here. And now we want to from that we want to subtract this. Now we want these three functions to be applied in succession. So I can't just copy them and paste them here. This will not work. Equals the mix of the sentences. So this doesn't work because of the way trains work. So this thing goes in here and in here, because this is being seen as a fork. And my instinct, it's not going to look pretty, but one way to fix this is by using compositions. So we can do that, but now this is heavily parenthesized. So I guess maybe not as satisfying, but we can have a short diff in here. Like this. So this is one way to handle that. Yep, I guess this works. Alright, so there you go. Our solution without using each. I'll leave it up to you to explore these two solutions I showed you and to figure out alternative solutions, and feel free to add them to the GitHub repository, because apparently when you comment with APL code, YouTube just deletes the comments. So feel free to make a pull request with your alternative solutions if that's something you'd like to do. Bye.